क्योंकि मैं एक्सेप्ट किया है, ठीक है वो ऑफलाइन, नहीं तो मुश्किल पड़ता है। इनमें ट्रायल नहीं रहता। शेयर होगा है ना आपका? हम्म। So I'm sharing Pratmesh some more documents. Okay, I think आपको I'll explain that also. एक डॉक्यूमेंट है, अगर आपको पूरा प्रैक्टिस करना चाहता है तो स्मॉल स्मॉल आरडीडी के ऊपर चालू करो। नहीं, इफ यू आर हैप्पी विथ दिस, नॉट अ प्रॉब्लम फॉर मी। और कोई नहीं आ रहा बस कल पे सारे See, I have shared this document, Prathamesh. शेयर ना, ये डॉक्यूमेंट में आपको अगर आप लोग प्रैक्टिस करना चाहता है तो ऑल स्पार्क आरडीडी के बद्दल हम है डिस्कस किया है ना, छोटा छोटा प्रोग्राम्स, सभी प्रोग्राम्स विथ एक्सप्लेनेशन है। ओके हाँ, अगर आप दिखा रहे हैं ना ये दिस इज देखो ट्रांसफॉर्मेशन एंड एक्शन ऑपरेशंस। ओके, दिस इज डेवलप्ड बाय डेटाब्रिक्स। ओके, यू कैन जस्ट सी डेटाब्रिक्स में से क्या है एंड आरडीडी एंड ऑल आरडीडी ऑपरेशंस क्या कौन सा है, एंड ईच ऑपरेशंस का इधर नैरो वर्सेस वाइड ऑपरेशंस। ओके, एंड दिस इज व्हाट इज नैरो, व्हाट इज वाइड, देन ट्रांसफॉर्मेशन का मैप। ओके, so then there is a what a map operations here. Okay, so after map what happens, then we have flat map, उसका प्रोग्राम है, थोड़ा छोटा प्रोग्राम पाइथन में प्रोग्राम है, so that you can go through this all most of the here things are here for practical. Even if you take just simply take this code, अगर समझो if you run this any code you take it, for example here is a union, अगर ये कोड लेकर उधर भी कट पेस्ट किया ना आपका डेटाब्रिक्स में, ये वन रन होता है। ओके, इधर कैसा है एक्चुअली, व्हेन आई स्टार्ट हियर, ओके व्हेन आई स्टार्ट कंप्यूट, so if I take this as it is command, first understand it, what exactly union does. I'm giving an example union here. Return a new RDD containing all items from two original RDDs duplicates are not called. Okay, so here example, x is one RDD, y is another RDD, z equal to x dot union of y. Okay, so z में दोनों डेटा वही होता है. If you take as it is data here and cut paste in the data bricks, it will work. Okay, this is one document. Second document is there. आप लोग को कभी भी आपको प्रॉब्लम आ गया हाउ टू क्रिएट क्लस्टर एंड ऑल. ओके, इधर दूसरा एक डॉक्यूमेंट है. वो डॉक्यूमेंट में मैं हाउ टू क्रिएट क्लस्टर्स, दैट इंफॉर्मेशन इज हियर.
सेटिंग
हाँ,
मतलब क्लस्टर डिसेबल हो रहा है, ऐसी कुछ सेटिंग जिसकी वजह से अगर हम लॉग आउट भी मारते हैं तो डिसेबल नहीं होगा.
see anything you use you have to pay money first of all, right? नहीं, I'm telling you, ये फ्री ऑफ कॉस्ट है. 24 तास नहीं चालू कर सकता क्योंकि उनका कंप्यूटर यूज कर रहे थे. किसका? AWS का.
तो
हर बार बनाना पड़ेगा. इट्स टेम्पररी ना, इट्स अ कंप्यूटेशनल यूनिट. यू आर नॉट लूजिंग एनीथिंग. हाँ, सेव एज फाइल कहाँ? नहीं, आपका क्या क्या डाउट्स है मुझको बोलो. हाँ, क्या क्या फर्स्ट यू मेक डाउट्स क्लियर. हाँ, क्या क्या डाउट इधर ये प्लेटफॉर्म में क्या डाउट्स है बोलो.
उसमें कोई भी वर्क कर तो क्लस्टर तो अपने आप 2 आवर्स के बाद अपने
अगर इफ दैट क्लस्टर इज इनएक्टिव फॉर 2 आवर्स, जब ऐसे इनएक्टिव, तुम इधर छोड़ा, अभी खाना खाने को गया, 1-2 घंटा आया नहीं, अपा दे क्लस्टर गेट टर्मिनेट. ओके, टर्मिनेट होने के बाद वो एनीथिंग दैट क्लस्टर वी यूज ना, इट ओनली टेम्पररी. एनीथिंग यू ब्रिंग अ डेटा दैट्स फॉर ओनली कंप्यूटेशनल पर्पस. आपका डेटा नीचे, अगर आपका समझो ये हार्ड डिस्क में आपका डेटा है. ओके, देन यू आर ब्रिंगिंग, यू आर प्रोसेसिंग हियर, पाइथन में आप प्रोसेस कर रहे हैं समझो, राइट? अगर आप स्विच किया, बंद किया, प्रोग्राम से सेव किया आप लोग. ओके, जब कंप्यूटर बंद किया तो फिर से जब चालू करता है, फिर से पाइथन चालू करना पड़ेगा ना. बट प्रोग्राम डिलीट होता है क्या? फिर से प्रोग्राम रन करो. सेम हियर ऑल्सो, that is a computational per use. So when I say computational resources you are using, their temporary disk, temporary CPU, temporary memory you are using. वो अगर वो 2 घंटा इनएक्टिव रह गया, इनएक्टिव कुछ भी नहीं किया आप, ओके, अब आप टर्मिनेट होता है वो क्लस्टर, बाद में आप रीस्टार्ट करो. अगर समझो आप लोग पेड वर्जन लिया यानी तुमको बोल रहा है वो मुझको आप कंटिन्यूस चाहिए, continue they will charge, they will give 24 hours into 365 days they will give you, but every second they will charge. If you are ready to pay, you can. प्रोडक्शन में हम यूज करता है ना, प्रोडक्शन में मैं 24 आवर्स रहता है वो, तो इसलिए हम वी आर नॉट बाइंग आवरली, वी बाय लीज बेस. मुझको 1 ईयर का लीज दो कुछ पूरा उनका स्पेस यूज करने का. हाँ, चार्जेस समझो, अभी आप AWS में अकाउंट क्रिएट किया, स्टार्टिंग में आपको 1 महीना फ्री रहता है. सम सर्विसेज यू कैन यूज फ्रीली. सेम थिंग विथ Azure also you can use 1 month free. After 1 month ना, they will charge for every service अलग अलग कॉस्ट है. अगर आप समझो SD Insight यूज करना चाहता है, ये Hadoop सर्विसेज hourly they may charge around, depends on again what is your requirement. अगर आप हेवी क्लस्टर यूज किया, ओके, मुझको 15 GB नहीं चाहिए, मुझको 60 GB का मेमोरी चाहिए, तो ज्यादा चार्ज देता है, दे विल चार्ज एनीथिंग. अगर छोटा मशीन यूज कर रहा है तो छोटा, अगर आपको इतना आपको थ्रू Azure से यूज कर रहा है तो आई थिंक यू आर सपोज टू पे आवरली कम से एटलीस्ट 200 रुपए देना पड़ेगा आवरली. ओके, इतना आप देना पड़ेगा. एक और कौन सा सर्विस आप यूज कर रहे हो वो उसका ऊपर है. अभी देखो आप पे हमारा एक स्नैप्स एनालिटिक्स सर्विस है, उसको 360 रुपीज पर आवर हम देता है, एक स्नैप्स एनालिस्ट का, जैसे एनालिसिस का। दूसरा उसका डेटाबेस का 86 देता है। कम से कम मुझको लगता है अगर स्पार्क चालू किया, AWS DW चालू किया, और सॉरी Azure SQL DW चालू किया, और सिनेप्स एनालिटिक्स चालू किया, तीनों सर्विस चालू किया, तो मुझको कम से कम 500 रुपए चाहिए ट्रेनिंग में। अगर if I want to teach Synapse Analytics, I have to start Spark cluster, SQL DW cluster plus Synapse Analytics। वो तीनों सर्विस के लिए मुझको कम से कम 500 रुपए पर आवर चाहिए। So that depends ना which services you are using, that is this is costly service, इसलिए वो लोग एक 1 नोड देता है ना, 1 नोड के लिए ठीक है, इट्स इग्नोरेबल है उनके लिए। वो भी ज्यादा भी स्ट्रॉन्ग नहीं देता, छोटा देता है, 15 GB रैम तो कुछ भी नहीं। And one thing please remember all of you, कुछ भी स्टडी करो आप लोग, दुनिया में कुछ भी स्टडी करो आजकल इसमें, without having knowledge on cloud,
क्या हुआ?
डिस्कनेक्ट हुआ क्या?
अच्छा अच्छा। घर पे के क्लास पे?
मैं घर पे हूँ, तू?
हाँ मैं भी घर पे ही हूँ। कनेक्ट क्लास का गया होगा।
हम्म।
that should not happen, so ensure that you should have some certification on which हम even we do certifications, I do certifications sometime, so junior को तो पक्का चाहिए। हाँ, क्या क्या डाउट है बोला मुझे आप लोगों को इसमें। आप लोग को ये आर्किटेक्चर अंडरस्टैंड हो गएगा डेटाब्रिक्स का। एक आपको मशीन दे रहा है बस उधर, वो मशीन कैसा दे रहे हैं आप लोग को, दे आर प्रोवाइडिंग यू लाइक ए वर्क स्पेस। एक मशीन है इधर, एक जगह है आपको वर्क स्पेस। ओके, इसमें थोड़ा कंप्यूटेशनल भी है, थोड़ा जगह रखने को भी है, थोड़ा इलेक्ट्रिसिटी कनेक्शन सब कुछ है उधर। एक वर्क स्टेशन बोलता है ना, वो लोग वर्क स्पेस दे रहा है। वर्क स्पेस हैज गॉट अ कंप्यूटेशनल यूनिट वेयर यू कैन परफॉर्म सम टास्क, एंड आप लोग इंटरेक्ट कर सकते हैं उसके साथ, देन थोड़ा कुछ स्टोर कर सकता है डेटा। वो कंप्यूटेशनल आप कर रहे हैं ना, इट्स प्योरली टेम्पररी पर्पस, that is the resources you are using na, Spark resource you are using na, it's only temporary purpose. Your persistent data is there in the disk, and that used for that computational resource you are using only for computation purpose. Computation means what? You may read a data, you may do calculation, these are all those things. पर कैलकुलेशन को आप रिजल्ट चाहिए तो उधर रिजल्ट आपको दिखेगा। अगर सेव करना चाहता है फॉर फ्यूचर पर्पस, यू सेव इट इन द डिस्क, अगेन कल उठा हुआ है डेटा। And this is totally on cloud, I'm telling you, it's on cloud purely. And backend they are using AWS. Backend they are using AWS. So here when I go to this, that's what the architecture I said already here. Architecture is like this. You are here when you are interacting na, you are here cloud services mein. Okay, this total is one workspace. Okay, now you are here. थ्रू हियर क्या है, वर्कशीट है. ओके, वर्कशीट है, इसमें क्या है, दे प्रोवाइड यू डिफॉल्ट जुपिटर नोटबुक टू इंटरेक्ट. ID means integrated development environment. They provide you something. So यहाँ से आप कुछ भी आप इंटरेक्शन कर रहे हैं क्लाउड का क्लस्टर के साथ. आप पहले क्लस्टर बना रहे हैं यूजिंग कंप्यूट ऑप्शन से, राइट. वर्कशीट ऑप्शन से आप जुपिटर नोटबुक थ्रू से कोड यू आर राइटिंग अ कोड. डेटा ऑप्शन से आप लोग अपलोड डेटा कर रहे हैं. व्हेन यू आर अपलोडिंग डेटा, अगर आप योर कंप्यूटर इज हियर, योर लैपटॉप इज हियर. ओके, लैपटॉप में आपका डेटा है, राइट. आपका डेटा इन लैपटॉप में डेटा, ये डेटा यहाँ इधर लेकर आना पड़ेगा. सो थ्रू डेटा आई एम ब्रिंगिंग हियर, तो ये डेटा इधर आएगा. मुझे इट्स लाइक योर लोकल डिस्क फॉर दिस. ओके, इट्स अ लोकल डिस्क. तो वहां से व्हेन यू ब्रिंग अ डेटा हियर, this data when I read through Spark, it will come here, it will distribute here, this data. Okay, you may be creating a RDD here, RDD gets created here only. Okay, and this you can access through Spark Master, and through Worksheet you will get a result. Right, अभी अगर आपका ये नहीं तो तुम लोग लैपटॉप में ये only this is what you are going to use in laptop. Okay, this is what you are going to use in a laptop, only computational emulator. बाकी में अब यूज नहीं करता है. इधर वो लोग पूरा एक मशीन दे रहा है, रेडीमेड मशीन, तो which you can use it. Right. So now coming back to wherever we have stopped morning. Okay, I think we have seen this, right? Reading data. अभी मैं डेटा रीड कर रहा हूँ, डेटा फ्रेम बना रहा हूँ. Okay, so data frame is part of SQL Spark SQL. Okay, RDD तो हम देखा yesterday. We have seen RDD, which is very bottom layer, without any data structure. Now on top of RDD, we are attaching a data structure. Okay, that is data structure plus RDD. What I can call it as a data frame. Data structure plus RDD called what? A data frame. Now anything today, RDD is kind of outdated now. I'm telling you. Why I'm not focusing on RDD? Your syllabus is showing more on RDD only. But today, RDD is no one uses because it's a little harder to understand it. Hence, they use directly a data frame. Okay, your machine learning is based on data frame. Spark streaming is based on data frame, and you are working with again data frame only. So whenever now, what is data frame? We have seen morning. Data frame is a collection of rows and columns. Okay, collection of rows and columns. It holds rows and also columns. But where it holds, it created as per this architecture. It creates here. Okay, when it comes to this architecture, okay, this when it comes, where is that? Yeah, when it comes to this architecture, your RDD get anyway it's created here. RDD created. When I say RDD get created means somewhere else it allocates a data space. Now that data structure is created in this area, and accessing this RDD through this data structure, and this is what I call it as a data frame. Okay, here you can this data, whatever data is there at bottom layer. So this data आपको पहले लेक्चर सभी लोग कैसा होता था?
मैंने पूछा था मैम वो 2 साल से
ओके, नाउ मैं क्या, so now you have created it. Okay. Okay. So now what I was just trying to say here, you are accessing, okay, if this is our core Spark, okay, and on top of that we have a Spark SQL. This is Spark SQL. Okay. Now when you say core Spark, obviously from the platform point of view, this is our architecture. Okay, maybe having 3 nodes here. And when I say node, each node has its disk, memory, and CPU. Okay. Here also disk is there. Here also disk is there. This disk is only for temporary purpose. Computational results are being stored over here temporarily. Okay. Now, when you create a RDD, when you create an RDD, this RDD where it is created across all nodes in the memory. It allocates a memory of all nodes. And actually, whenever you have a data, okay, suppose when you read a data from source, from the disk, so data will get distributes across all nodes here. Okay, and when the data brings into a main memory, temporarily it stores here in this disk temporarily. Okay, now if you do any changes, okay, if you do any changes after creating multiple RDD, suppose you have created one more RDD, you have made some filter operations and you have created one more RDD, and this filter result, if you want to save, you can save back here. Result can be saved here in the disk permanently. Otherwise, because if you don't save it, the results are here only. Agar वो terminate हो गए तो whatever it is there in this, you lose everything from this place. Okay, if you want to store, you have to save into disk, persistent disk. Now, this is an RDD. You have okay. So now what I am creating a data frame which is pointing to RDD internally. Automatically, when you create a data frame, internally RDD get created. Okay. So data frame includes RDD. Please remember, data frame includes RDD, but RDD do not include Okay. So now in the morning, what we did is that we have a data coming from different sources. Okay, one source is a TS or a CSV file. Okay, this data we have read through data frame. We have read a data, we brought a data and created a data frame. Internally, automatically RDD got created. And whatever operations we can perform operations on data frame. We can perform operations on a data frame. They are called a data frame operations. So data frame operations, again, like RDD, data frame operations are also two types. Now, in the morning, what we have seen, we have read a data which are of different formats. Perquit format, CSV format, TSV format, JSON format. Okay, these are all formats of data coming from different sources because different application can generate different types of data. Okay, suppose if your data is in TSV format, I should be able to read it. Okay, if your data is in CSV format, I should be able to read it. If it is in a Perquit format or JSON format, I should be able to read it. So now you have a data in different formats here. This data we have read and create. Based on this data, we created a data frame. Based on this data, we created a data frame. Once the data comes in this area, okay, whatever this format is there now, is the same data. Either JSON format has to be in data frame, it is the same. In cluster or in Spark, it is the same data. Even if you read a data in TSV or CSV format, when you bring this data into a, say, cluster, it is the same data. Okay. So now you created a data frame based on these data sets. Okay. When you created a data frame, okay, so you have automatically internally it creates a RDD. Okay, though you are creating a data frame, internally, automatically it creates an RDD. Now, how to create a data frame? What is the syntax we have seen in the morning to create a data frame? What is the syntax we have used? How we have created data frame? How we have created data frame?
Yes.
Which one?
Create dot.
Huh? Morning I have shown, no? Suppose data frame name. The syntax is okay, name of the data frame name equal to, okay, Spark dot, okay, then what is that?
Read.
What is a Spark dot?
Read.
Read. Okay, which Spark dot read dot CSV, then you give a file path. Okay, you give a file path. If you are creating a data frame based on CSV, comma separated value, okay, you can use straightaway Spark dot read dot CSV. Suppose if you are creating a data frame based on Perquit file, data frame, okay, data frame equal to Spark dot read dot Perquit and file path. Okay, this is the what normally we use a syntax. Right. In addition to this, there are some options we have. Okay, there are some options here. We can use with the options. What are the options? First option is what? Suppose if your file comes with header, I don't want to take first, if it's a header is also there, that way I don't want to consider that. I want to consider as part of metadata. In that case, what you do is option header, comma true. Means you are skipping first row as a header. Now by default it returns data type. Okay, that's a string data type. Suppose I want to infer as it is data types. Default anyway it returns data type. That's a string. But some columns are having a date type or integer type. I want to return exact data type. For that, what is the option we use? Option. Here we use a dot option. Here option. Yeah, what is that? Dot option infer schema comma true. Means you are going to infer the schema. Okay. Suppose if your file is coming with a different delimiters. Now it's a comma is default. If your file is coming with a pipe operator, pipe is a, like if your file is having employee name, pipe, employee date of joining, pipe, employee location, pipe is your delimiter. So which option you use it? Option separator. Separator, comma, you can use a pipeline. Okay, so these are all options we use. Okay, options we use. Otherwise, if it's a plain line, plain program, we don't use this. Right. So suppose if your file is coming up with the like this, there's a customer file. Okay, customer file is having what a customer ID, pipe, customer name, pipe, then customer location. Okay, now customer ID is 111, comma, Desai, comma, sorry, pipe, Pune. If this type of data comes, 222, pipe, Kumar, pipe, say for example, Mumbai. If this type of data is there, now I want to read this data because this file is having first name is a first row is a column names also. Each field is delimited by pipe. Right. Now how to read this file? Suppose if I want to read this file, how do you read this one? Data frame like a cust df equal to spark dot. Okay, before read, we can use option here first. First option is I want to consider first row as a header of the file. For that, what is the option here? Header, comma, true. Okay. Second option, I want to infer the schema also. What is that option? Option infer schema, comma, true. And suppose if I want to, I know that file is delimited by pipe. What is that? How to do that? Option separate, separator is comma, pipe. It's a pipe. Then you read it. Okay, CSV, then whatever the file path here. File path. This is what how you can use it. Okay, so it means that you are creating a customer DF. So here customer it creates a customer DF here. Customer DF is here, and actually data when you bring data will be here. in the course part. Okay. Are you clear?
Yes.
Now, this data frame I can create to read data coming from any source. I think morning we have read a Perquit file, we have read a JSON file, we have read CSV file also. So remaining, what you can do, you can continue with the other part. Okay. So we have a JDBC, we have a text, but you have to take an effort and complete this practical. Now, once I bring a data here, now I bring data from any source into a cluster. Now I need to process that data. I need to analyze the data. In order to analyze data or in order to process the data, okay, they are called what are data frame operations. Data frame operations. There are so many operations we can perform. So these operations are divided into how many types? 2 types. What are those? Transformation operation and action operations. So what a transformation operation does?
Filter, distinct, join.
What it does? Sorry? What transformation operation does?
Check the
Huh?
check the
Transform. What is the purpose of transformation operation? Like filter or anything. What is the purpose? It creates a new RDD. So here, when I'm talking about a data frame, it creates a new data frame. It creates a new data frame. Right. So now, what type of operation it is? Is it lazy operations or eager operations? It's a lazy operations. All transformation operations are lazy operations. Spark itself is a lazy. Unless and until you take action, that will not perform. What are the actions you can take? One is you can count the number of characters, number of lines. You can display, you can show, you can save. Okay. Now, if you are going to use a RDD, that's a collect. Okay. But in the same data frame, show is there. Okay. Collect is at bottom layer, show is at top layer. Using show, you can see the data. Using in RDD, using collect, you can collect the data. Okay. Now, once I bring a data, I have to perform operations. Some of them are action operations, some of them are transformation operations. We'll see few transformation operations here. The first transformation operations, you can see here, these are all few operations. Okay. Limit, select, drop, distinct, drop duplicates. Limit means you have thousands of records, but I don't want to take all records. I want to limit only 50 records. When I want only 50 records, I can use the limits operation. Okay, I can limit operations. Now, if I use a select option is required only to select required number of columns. It is used to select the required number of columns. Right. Same thing, drop is there one more. Drop is used to drop unwanted columns. Unwanted columns. Then we have drop duplicates. So drop duplicate is used to remove duplicate records. And here, the same way we have a distinct. Distinct is also used to remove duplicate records. Distinct, remove duplicate, drop, select, okay, limit. So these are all what are kind of a transformation operations. So here, select also does the same thing. Drop also does same thing. Select means you are selecting only required number of columns. अगर मेरा data structure में 10 column, I want to select only 5 columns. So I can use a select data frame dot select number of columns. Okay, I can select out of 10 columns, I can select only 5 columns. Same way you can use a drop. Drop means you have a 10 columns, I want to drop out 5 columns.
So you can also drop it, drop.
Huh?
You can drop rows.
You can drop them. That's what remove duplicates is there. Okay, limit is there. You can drop using limit means what? अगर 10 रिकॉर्ड है आपको only 4 रिकॉर्ड चाहिए. अगर out of 10 record you want only 4 records, remaining 6 records you want to drop out. Limit is only 4. First 4 records are selected, last 4 records are dropped. And one more thing is that since these all operations are okay, based on operations you are creating a new operation, new data frame. Can you hear?
Yes, sir. Driver is using.
है क्या ऑनलाइन कोई भी? है क्या अभी See here, suppose here you can directly see example. I'll just show you directly. So I told you a limit is to limit number of records. अगर मेरे पास 100 records है, I want to limit only 40 records. 100 से 40 only I will pick up. But you don't have any choice that which record you have to pick up. First 40 records only you pick up. There's a limit. Second, we have a select. Select is used to select only a required number of columns. अगर आपका पास 10 कॉलम है, but I want to only 4 columns. I don't want a remaining 6 columns. आप प्री प्रोसेसिंग में क्या करता है, आपका जब डेटा रीड करता है, मे बी 100 columns are there, but all 100 columns are required for your prediction, right? You take out some columns, right? So that's what here you can do it. अगर आप मशीन लर्निंग में काम करने वाला है तो अगर आप प्री प्रोसेसिंग करना पड़ेगा बिफोर मशीन लर्निंग इज वन पार्ट. बिफोर दैट यू प्री प्रोसेस द डेटा. ऐसा नहीं है आपका वो डायरेक्टली डेटा रॉ डेटा उठाएगा आपको डेटा में मशीन लर्निंग को देगा, ऐसा नहीं ना. सो इन बिटवीन यू हैव टू प्री प्रोसेस द डेटा. व्हाट यू डू इन प्री प्रोसेस? प्री प्रोसेसिंग में क्या करते हैं आप लोग? Sorry, you can filter null values. Okay. Categorical into some non-categorical value. Drop the unnecessary columns. अगर वो इधर drop हम किस लिए यूज करते हैं? Dropping unnecessary columns. Select क्यों यूज कर रहे हैं? Selecting only required columns. Dropping unwanted columns and selecting required columns both are same, na? Whether telling you are my son-in-law, so I will tell reverse way you are husband of a daughter. Both are same, right? Instead of telling directly, we tell indirectly. Why they have made two statements? I will tell you why. When they are developing this Spark 2.0 and later, they have kept in mind that developers can be any background. Maybe a programming background or non-programming background. Programming background, they may be from C, Java, .NET, Python. These are all what a different data programming background. Some people like a non-programming background, like a database background, people are also developers are also there. They should also understand this. Okay. So people who are from a programming background, for them easy understanding is a drop. Okay, those who are coming from non-programming background, for them select is easy to understand. selecting only required number of columns. Okay. Or, for example, अगर आप प्रोग्रामिंग बैकग्राउंड है तो remove duplicates is easy to understand, right? For non-programming background, distinct is easy to understand. Both does same thing. ऐसा नहीं वो अलग करेगा, distinct अलग करेगा, remove duplicate अलग करेगा. Both does same thing. But when they have developed Spark 2.0, they kept in mind that developer can be any background. Why should I stick to only row remove duplicates? Let me put you one distinct also. Okay, क्योंकि let programmer from developer from non-programming background can also work with Spark. Okay, all are same. Remove duplicate, say drop and select, both are same. Distinct and drop duplicate is also same, but only they have made keeping in mind two types of developers. Clear? Okay, now coming back to this. So we have seen some files here. Okay, now let me attach this cluster to this cluster, this particular. Now I can run here that particular script. So these are all few files which are there in this particular directory. Okay, now these files I want to read, then I want to perform some task. So how to read? In that case, I have to create a data frame. Whenever I want to read a data, I have to create a data frame. So how do you create data frame? You know that data frame name equal to spark dot read dot perquit, because if it's a perquit file, you have to read a perquit file here. So now here, what is that? Here in this case here, what you have done? You know these are the files. Okay, each file has certain records. Okay, now if I want to read, these are all files, like these are the partition files. And all are there is as part of single directory only. You can see this only one directory is there. Okay, this is only one directory, these all files are there. Now if I want to read these files, here I can read a file, I can create a data frame. Okay, so how to create data frame? You know already syntax. Data frame name equal to spark.read.perquit and file path. Right. So once I read this here, in this case, I am doing same thing. I am creating a new data frame called page counts enrdf. Is the name of the data frame. So now I can run this query. It creates a data frame. Now print. Print is what? Print is like a Python command to print whatever the contents. So now here, if I want to display data structure of page counts enrdf, is the name of the data frame. If I want to see a data type from that particular, say, data frame, I can use a print statement. Otherwise, you can also use a data frame dot, how to see a schema? Print schema. Data frame dot print schema. If you use, it will also display the schema. So now here we are just printing a schema. Okay. And here I am reading a data and creating a new data frame. I can run this. Now we have created a data frame called a page counts enrdf. And this is a structure. Like project is the first column, article is the second column, request is the third column, byte served is the fourth column. Okay, now after creating a data frame, I want to see some records of that data frame, because data is there at bottom layer. Based on that bottom layer file, you have created a data frame. So now based on the data frame, I want to check how many columns are there in the data frame. Because based on data, you can see a number of columns here. So there are 4 columns: project, article, then we have some other 2 columns. there are 4 columns are present in that particular file. Okay, this is also data coming from a Wikipedia. This data is also what they have taken from the Wikipedia. So this Wikipedia, let me give how to interpret this data. Whenever Wikipedia is created, okay, you can type Wikipedia, you can get in any language, right? It's not only in English or Marathi or Hindi. Okay, if you want, you can get Japanese, you can get even other countries' language also. Now, Wikipedia has a different projects, like India project, Wikipedia India. Then you may have one more server in UK, US. So Wikipedia UK. Okay. Whatever projects, they'll make one project. If it's only English Wikipedia, it will make it as English. English.New Jersey. New Jersey project. Okay, like this, there are so many types of projects are there. All projects are stored under project. All different projects are there. You can identify this is an English project. EN stands for English. And this is the article which belongs to English project. How many requests are there for that particular article? Only one request. Only one might be requested. And for that particular request, it has written 0. Now you request, right? I also request, you will also request. If you are requesting same document which I am also requesting, the count is 2 there. Because 2 people are requesting, like that you can interpret. And for every request, okay, we may be able to see document, but not full at one stretch. अगर आपका 10 पेज है तो 10 पेज डायरेक्टली 10 पेज नहीं दिखाएगा ना. First page दिखाएगा, then control enter, then you get the next 20 pages like that. You can read the data. Okay, so here that's why byte served means whenever we request for a particular article, it will give only a 5 lines or 1 page only it will give. अगर वो 100 page का article है, if I want to read, okay, when I open it, I may read only 1 page. Later page, it may ask you to click so that you can read the next pages. So here, when you request for the article comes not full article, they will give 1 page, then click more to view other article. Okay, so that's what byte served means. That is the means how many when you have a request, when you are sending a request to Wikipedia server, I give that data to you. Not 100% data. Maybe first I will give, if it is 10 page, you will first see only 1 page. Then immediately you may, second time you may see 5 pages. Okay, so step by step it provides. That's what number of articles request bytes. This is what a number of bytes it served when the requester has come. Now this is the data. Now you have created a data frame here. Now I can also show that data. Okay, I can show the data. So show somewhat ugly command compared to display. You can see this data. Okay, once you see this data, now I want to how many records you have selected. If I want to count them, what do we do that? Count star. Okay, the data frame name dot count. Data frame dot count. You are going to use it. So it is similar to a count star. Means if you use a count star, means all columns it selects. So here also it uses what a count. It counts number of records. Okay, now here you have already created a data frame. Now I want to perform a count operations here. Okay, here count operation which counts number of records. You can select and execute this particular shell. So here it got 2, 3, 4, 5,000 records. Okay. So now what happens here? If you see this particular diagram, okay, this is your diagram. Your data, where is your data? Your data is here, somewhere else, S3 bucket. Okay, you read a data will bring here. Okay, you read a data, then it will get distributes across all nodes when you read a data. So some data is here, some data is here, some data is in third node also. Data get distributes. On top of that, if you perform a count, okay, count, whenever you use a count, that's an action operation. So your data get traveled from S3 into computational resource, then it perform a count operations. Okay. Second time, the moment the count session is over, again it releases data from the memory. Okay. See, now let me perform a count. When I use a count operation here, every time you have to bring a data. Every time you have to bring a data here. Otherwise, it do not hold into main memory. Okay. If you want to hold into a main memory, you have to hold in cache memory. Okay. Suppose if you don't bring data, or if you every time you are bringing data, means that may impact on the performance. Okay. Because here data has to come from every time here, your data is decided here. When I use a count, then it will bring a data transfer here, send it to all nodes, count. Again, after count, it releases data from here. Again, second time also you bring it, again it perform a count operations. Every time data is traveling from a storage account into a main memory. That may impact on the performance. That may impact on the performance. Hence, we use basically a cache in between. Cache is also one operation. Cache is an operation which holds data in computational resources temporarily. Temporarily in the sense, until you release, it will be there in memory. Otherwise, if you don't use cache, the moment data it brings, perform operation, release it. Okay, when you use a cache here, it brings the data first, bring here, do a computational, and data is also stored here temporarily. Second time, if you use a count, data will not transfer from here to here. Because your data is already available in this place. Because you have hold them, you hold the data. If you don't hold data, again it releases data. Right? Are you getting what I'm saying? Okay. Your cluster is here. Okay. And your data is here. I am performing a count here. When I use a count, first I have to be creating a data frame. When I create a data frame, it creates data frame here. Okay, bottom layer anyway RDD is there, which holds the data and all. Okay, this is RDD. At bottom layer the data frame. Okay, now when you use a count, okay, so what is that? My df, okay, dot count you use it, right? When you use a my df dot count, that time it brings the data from here, okay, which will get distributed to all nodes, okay, then perform a count operations on this. Once the operation is over, data get released from here. Again it's blank. Again same second time if you run same command, again it brings data from the disk into main memory, distribute here, okay, then perform a count operations, then release it back. Because it has to manage memory. It has to manage memory, otherwise it memory become full. Right? Memory become what? Full. But since every time data is traveling from disk into main memory, so this takes some milliseconds. Okay, it takes some milliseconds, it may impact on the performance. So, if I know that this, I'm going to use this data frequently, then what's the point of using every time you are going to bring a data? Can hold one time only, I can bring data, store here data in this location. Temporarily store it. For that, we use a cache. Or I can use a persist. There are two functions that we use, cache or persist. Okay, so cache, if I use the cache or persist, then the data will store in this location. In the cluster, data will be stored. Okay, when you use a uncache or unpersist, this is another function, it releases the data. So it means that when I'm using cache, this data will be held as long as I need it. जब मुझको चाहिए, till then I will store the data here, I hold the data. When I don't need it, I will release it. Right? So how to hold the data here? Data frame mydf dot cache dot count. If I use this way, I bring a data, I hold it, then I perform a cache operations. Okay. Now I will tell you before without using cache, how much time it takes. After using cache, how much time it takes, I'll tell you. And you can just see this here. Okay. Now I am reading a data here. Okay. When I'm reading a data, run this one. When I run it, I'm just running the data. I am not taking any action here. Okay, here I will take a action in this place. Count. I use a count. When I use a count here, okay, first time I'm using count. See how much data it takes. How much time it takes. 1.70 seconds it took. Yes. Okay, it took 7. Now run once again data. Run once again, because again it takes 1.17 seconds. Even if you run once again it's taking 1.03 seconds something. But you bring a data in main memory, perform the task, then release it. Now I will let me hold the data here. For that I told you cache. Cache or persist, one of them we can use. Cache or persist, one of them we can use. So cache, first I create a data frame dot cache. Then I use a count. Okay. First time your data is here only. First time your data is here. Line is here only. When you use this statement, data frame dot cache count, first time data has to travel. Okay. So this time will be there as it's like 1.7 is there, and it will take this time, this much time. Okay, you count for first time your data, your timing is same. But second time, if you use second time count operation, your data is already available here. So obviously this time will go remove this, reduce it. Now here, when I use this cache, let us take this time. First time I am run this statement. When you run this first time data has to travel. So it takes what? See the timing here. Timing is what? How much? 8.93 seconds. Whatever it is, 93 seconds. Now once again you run it. Now you have already you have used cache here. Okay, when you use a cache, run once again. 0.51 seconds. If you run once again, maybe that much only. So where is 1.93 or something 8.93 seconds and where is 0.42 seconds? Because when you are already bringing the data into the cluster and from there only you are performing the operations. That's what cache is also one of the operations which you can use for optimization purpose. Okay, for performance. Okay, cache can be used for what? The performance purpose. Now, coming back to this some other part here. Okay, now when this data will be held on memory as long as you unpersist. अगर जब नहीं चाहिए आपको, अगर हो गया मेरा काम, why should I hold on memory? When I bring data, I perform the task, I don't need this data. Why should I keep? I release it. Okay, to release it, I use the unpersist. Persist, unpersist. Cache, uncache. Cache means it holds data temporarily in memory. Uncache means release data from the memory. Persist and uncache is say both are same. Okay, here if you don't want, you can just use a name of the data frame dot unpersist. So here you can release the data. Right? Now coming back to this. Okay, you know that when I take this particular data, when I'm reading a data from the Wikipedia, these are the 4 columns. Okay, what are the 4 columns? Project, article, request, bytes. There are 4 columns. Agar mujhko, okay, I need only 3 columns out of these 3. Out of 4, I need only 3 columns. What is that? Project, article, request, only columns I need. Okay, how to select only required columns? Sorry? By using select, it's not called a statement, it's called a select operator. Or select operation we can call in this terminology. So how do you use? So here the project has this type of data. I think they have given you a description about data. What that under that column, what type of data is there. Under project, okay, you have a sample data like en, fr, en.d, fr.b, da.n. So this means that project means the Wikipedia project. If it is in Hindi, different name. If it is English, different name. If it is French, different name. If it is Chinese, different name. Okay, so to differentiate whether it's a Hindi or Chinese or Japanese or French, so they have made a different project here. If you can just see, EN means the English version of Wikipedia. FR means the French version of Wikipedia. EN.D means the English version of Wiki Dictionary. FR.B means the French version of Wikibooks. D.N means German version of Wikinews. Something different. Each project they have given a different names. They have kept under project. Article, there are so many articles are there. Okay, like maybe example like Apache Spark is one article, Zoharia is another article, Kevin is like this, some name of the articles. So if this name article is English article, then the under project name, project it is an EN and article is Apache Spark. Request, the number of requests the article has received in the hour this data represents. How many requests? Suppose when the article get published, people start requesting that article to read. Okay, you may be searching, right? When the new movie get released, what you people do it? You start, go to my booking, show my, what is that? Book my show, then start booking the ticket or see the review of the movie. Right. So here also, when the moment new article being published, people start viewing that article. That is a request. Then byte serve, every request it will not serve. Okay, agar now you want to read an article, Okay, it may be having a 10 page. When you click on that article, you'll not get to pay all 10 pages. You'll get 1 page, 2 page, 3 page, then click more to some more pages. It will not that much, it is only serving. Okay, that information is how much served for every request that is there under a 4th column. So out of these 4 columns, if you want only few columns, I don't want all columns. I want only few columns. Now, to get those few columns, what is that? What you use? You use basically a select. Okay, so before select, you can use a limit also. What for limit is being used? To restrict your number of records. Okay, now you have how many records in this place? In this file, you may be having so many records. Okay, here I think you may be how many records under cache? 2, 3, 4, 5,000 records are there. Right. So 2 lakh something records are there. Now out of this, I want to limit to only few records. Okay, if I want to view only few records, so how do you do it? Okay, how do you do it? Limit df equal to. Okay, then I use this particular name of the data frame because I have to refer a previous data frame. Dot limit 5. Okay, dot limit 5. Only these 5 records I want to hold into a new data frame. That's called a limiter df. When I run this, so 1 minute, 5 does it here. So here, now limit df, how many records are there? Only 5 records are there. Instead of limit df dot show. When I use this, limit df have only 5 records. Not a top 5. You can say first 5 records. Yeah, you can say top 5 records. Okay, top 5 records you can say. Okay, so first 5 records from the top of the file. If you use limit 50, it makes only 50 records. Okay, you have a 50 records. You can limit to, and you are creating what? A new data frame. It means that when you are creating a new data frame, what type of operation it is? What type of operation it is? Transformation operation. Okay, so now this is what one transformation operation. Second transformation operation, now you know there are 4 columns. I want to take out, okay, I select only 3 columns. I don't want 4th column. What is in 4th column? Byte server. How to select only required number of columns here? Okay, what I will do that? I will take first this data frame. Okay, I will take only 3 columns. Okay, 3 COL DF equal to 3 COL means 3 column data frame. I am giving a name, you can give any name. Now, what I want to do, how many columns I want to select? This page counts ENRDF has 4 columns, out of which I want to select what? Only 3 columns. Select column name. What is the column name? If I want a project, I can use a project. It should be within quote. Then I want an article. Again, it should be in the quote. And third one, if I want even request. Okay, so only 3 columns are being selected out of 4 columns, and that is being stored into a new DF. Okay, When I run this command, okay, it holds only 3 columns. What is that? Okay, article correct is here. When I run this command, okay, you have only 3 columns here. How to check whether it has a number of columns here? Show is different. How to see a number of columns? Display also no. I want to see whether number of columns. What print schema does? You are printing the schema, right? That tells you that number of columns here. You have only, what is the print schema? Schema, you are used 3 column DF. For that you use the print schema. Where is it? Whatever this. Yeah. Limiting 5 records. And now, if I am using a select, okay, now you know that print schema has a 4 columns. If I use only 3 columns, the new data frame is only 3 df equal to page counts en all df dot select, and select the number of columns. And now if you want to print that schema, you can print the schema. It has only 3 columns. Now there's another way. Okay. Now only 3 columns are there. Okay. Now, I think limit already you have seen. Limit means I want to take only 5 records or 2 records or whatever you can limit that many records. Now, in the same way, you have, I'll just show command what it does. Basically, it will display the data. It's an action operation. When you are using a show command, only it prints a 20 size. If your file, your column size is more than 20 bytes, it truncates remaining columns. Okay. Now, when I use a true here, it truncates. So now I don't want to truncate the column. Okay. That's what I can use a show 5 records only and false. I don't want to, suppose if you see a true here, what happens? See that. See the difference. False only. What was it earlier? False means I don't want to truncate any columns. Otherwise, if I use only this much, okay, without using false. If I use only this much, what happens? See, if 5 records will be there. See here, some of the data get truncating off. If I don't want any truncating off, then we use false. Okay, it doesn't truncate any data. It does not truncate anything. Now, this is what we are using. The one is a select statement. Second, we are using what? Drop also. Both are same, I said. Either you can select required columns or drop unwanted columns. So now in the same, you can see here. Page counts ENRDF has 4 columns. Now I want to drop only 1 column. Okay. Out of 4 columns, if I drop 1 column, remaining columns are taken. Okay. So page count has a 4 columns, drop byte server. Means I am dropping 4th column. So it means that automatically the new data frame has only 3 columns. Okay. New data frame has only 3 columns here. Dropped DF equal to how many columns are here? Only 3 columns are there. Automatically you are dropping a new column, one of the column, unwanted column. Or okay. Now in the same way, we have a distinct and drop duplicate. Both are same. Okay. So distinct means you are distinct. You are selecting only distinct records. Drop duplicate means you are removing unwanted or you are removing duplicate records. But if you use a distinct, it means that it is applicable to entire line of the data frame. It's not like a distinct of your MySQL. Okay. In MySQL, you can use a distinct, the column name you can use it. Here is not the case. When I use a data frame, whatever number of columns are there, and if I use a distinct, this distinct is applicable to entire data frame, entire line. Agar if I want to select only distinct with respect to a column, then select only 1 column. Then apply distinct. Okay, that this data frame has only 1 column, automatically distinct will be applied. If you take this example, okay, we have anyway that has a 4 columns. Now, how to out of 4 columns, I want to apply a distinct operations on a project column. Okay, how do you do it? First, select only project column. How did you select? How do you select only project column into a new data frame? How to select only project column in a new data frame? What is the command? I want to select only a in new. I have already one data frame which has a 4 columns. Now I want to, on top of that, I want to create a new data frame. This should have only 1 column. How to do that?
Data frame name.
Huh?
Old data frame name. Select and in bracket give
column name. Correct. Now here the same thing I am doing here. Is a new project, new data frame name equal to old data frame which has a 4 columns. Dot select, only select. Okay, only I am selecting project column, and for that project column I am applying a distinct operations. Distinct operations here. So it means that you are applying distinct to only 1 column here. So these are distinct values. There are so many projects are there. Like you can see en.m, en.m.q, en.m.s, en.0.y. So these are the different types of projects are there as part of a project columns. Is that clear to you all? I'll give 10 minutes complete the practical in front of me. Now do it. आपका सब कुछ है आपका पास, कोड है, मशीन है, only you have to understand it. Do it in 10 minutes. आप लिखिए. Okay, this is the introduction to part 1. Now we'll go to introduction to data frame 2. I was there in marriage here only. Day after, if you cross that bridge, na, there only I was there. But I came with different dress. That's the problem. I have to go all the way to just to change dress and come. Otherwise, at 2 o'clock I would have come. 1 o'clock I was free. Quick. I will cover this, then you have to do a remaining part because this is required for your data pre-processing part as part of ML. I think Kalpesh is asking 10 minutes break. Yeah, guys, you can take a break, Kalpesh, and complete introduction to data frame part 1. Very challenging after lunch. Okay. So now, Kalpesh, are you there?
Yes.
What happened? Break. Break. क्या होगा? ब्रेक चाहिए बट ब्रेक दिया था नहीं भी. हाँ नहीं DF2 I will explain. Okay, DF. Then I will give some 3 and 4 आप घर में करो आप लोग. Okay, then I will give some hint on here. Okay. So here, yeah. Ready? Okay. Now in this part, what I'll discuss about some more operations on data frame. Okay, so these operations usually we can see that order by how to sort a data. Again, in order to sort a data, we have two commands, two operations on data frame. That's the order by operation, or you can use a sort operation. Again, as I told you, order by operation is easy to understand by people who are coming from non-programming background, and sort is easy to understand by the people who are coming from a programming background. Same thing, filter and where. Suppose if I want to filter a data, I don't want all data, I want to filter only certain data. So in that case, either you can use a filter or you can use a where clause. Again, both are same. Filter and both also same, where is also same. Okay. Now, these are all what are transformations operations. Okay, you can see here, there are transformation operations. Now, action operations, collect, already I told you. Collect is an action operations. Second, you have a show is an action operations. Take is an also action operations. Take means you can take only a certain amount of data. Collect means it collects all records. Take means only suppose I want to like a limit how you are doing now. Take 10 records. I take that take is there. Head means it will read data from the top of the file. Okay, these are also few operations. Okay, but these operations are not a data frame operations. Basically, these operations are RDD operations. Take, collect, head, and first. So let us say how we perform operations that are here. Now we know that there is a file. Let me read that file, like whatever that we have. Page counts en or df. All data is there which are related to Wikipedia. I want to read it. Okay, I want to cache also. And I want to create a data frame. What is the name of the data frame here? Page counts en or df equal to spark dot read dot a perquit, that perquit file name, and I want to cache it. Okay, I want to hold temporarily into a main memory. So select resource means why it is, because I have to attach that this particular notebook to that cluster. Okay, this is a cluster. I will attach this. So here it should show green. Okay, now I can run this. Once I run this, okay, now I have created a data frame and structure is this, like project, article, request, byte served and all. Okay, now you have created a data frame. Now I want to know how many records are there. I think already you said 2,345,000 records. Okay, around 23 lakhs records are there. Okay, so this many records are here. But what I can do here, I want to, already I told you, you can use one, this total. I'm counting records. I'm storing into one variable. Okay, total is one variable. In Python, how to create na, that total equal to whatever output of a count, it will be returned and stored into a variable called a total, and that I'm printing here. Now display command. What is the difference between display and show? Show also shows the records. Display also shows the records. The output you have seen, right? Both. Display output is somewhat cute. Okay, like it looks like a table and all. Okay, it looks like a table. Show means it's like ugly. It does not just, it will display data. Okay, and one more thing is that display 1,000 records default. Show display only 20 records by default. Okay, show it's display only 20 records. Second thing is that show is Apache Spark command. Show is Apache Spark action operation, but display is not. Display is a Databricks action operation. Databricks kind of. Where when you are using a Spark, it doesn't. Okay, this is the difference you can see. Now, if I want to sort a record, okay, sorting means you know that you are arranging a records either in ascending or descending order. When you are ascending or descending order, if you are doing, you have to, you cannot just like that, you cannot sort, right? You are having some key column for sorting a data. Okay, you have to have a one key column to sort a data. Without that, you cannot. Okay, so you have some number of columns here. Project column is there, article column is there, request column is there, byte served column is there. So on all columns you cannot sort. Okay, you can select one of the column to sort. I think in any language, if you are sorting or if you are grouping, you have to have a key column. Okay, like even in RDB, MySQL, you have sorted data. There should be only key column for that. So here, order by and sort both are same. I said what it does, you can see the here documentation. It returns a new data set sorted by the given expression. Means when you use the order by or sort operations on the data frame, it sorts a data and returns output. Okay, returns sorted output into a new data frame. Okay, it returns a sorted output into a new data frame. When it is creating a new data frame, then what type of operation it is? Transformation operation. Sort by or order by is also transformation operation. Right. Now, here, if I want to sort here, what I can do? Data frame dot order by. Data frame dot order by and column name. So based on that column name, what is the column name here? Request is a column name. Request is one of the column in the data frame. If I want to sort a data based on request column, this is the I can use it. Data frame dot order by and column. And if I just say run this command, it sorts the data, okay, in request column. Now when you use a request column, by default, it sorts in ascending order. Any tool, not only this tool, in any tool default, it always sorts in ascending order. Suppose when you want to use a descending order sorting, you have to pass a parameter. That parameter is what? A DSC parameter. Okay, DSC parameter you have to pass, then it takes you are going to sort a data in descending order. Okay, now here you have sorted here. Now your request, based on request, you are sorting in ascending order. So you can just see this is what all 0 will find here. Okay, all 0 only because it started with a 0 0 only. Okay, starting with a 0 0 only. Suppose if you want to sort, I think request request only. It's all one. Request is only one only. Let us see some other data. Is there here down? No, because all are one. There may be some more records where requests are 300, 400 like that. But since it's in ascending order, since it is displaying, it can display only 1000 records. So here you can see the 1000 records. Till 1000 records, requests are only one. Maybe later it may be there. Okay. So now how do you know that if I sort in descending order, I know that. Otherwise, you feel that it is not sorted. Okay. If you want to understand if it's sorting or not, then you make it descending order. So to descending order, if I run this command, okay, like this, okay, here it throws an error. It throws an error because here earlier I have executed request is one column here. Okay, and now if I pass like this, anything you put into two strings, then it's called one string, two double quotes. So it's called only one string. So what is the string? Request space DSC. It's considered as a single column. When it considers a single column, there's no column here. Request space DSC column is not there. Request column is there, but request space DSC column is not there because both are in double quotes. Both are in double quotes. So first what we need to do, we have to take only request column. Then that request column you can pass it to a DSC. So now you have to pick up only column. In order to pick up only column, then there is a function called call function, COL, call. So you have to use this call function, then you can use a DSC. There, okay, whenever you want to use a call function, you can call, okay, you can call a column class. Means it's one column class you have to invoke, and that column class help you to select only a column. So this is in Scala. Okay, now I'm talking about a Python. This is in Python. So whenever you want to use a call function, okay, so you can import this library from pyspark.sql.function.import. All required library you can import. See, now if you use call function COL request. Okay, if I run this command, so column C is a variable which holds value requests. Which holds value request. This is one way. Suppose if you use a column D, this is another variable equal to expr a plus 1. since it's a double quote, within double quotes, it's considered as a string. A plus 1 which doesn't add the value 1 to a value and print it. No. A plus 1, it is there in double quotes, hence it's considered as a one string. Okay. So here also it prints what? Column D prints what? 1 plus A only. Suppose if I use this column E equal to later within double quotes ABC. Literature within double quote ABC. So here also that column E holds ABC value. Column E holds ABC value, column D holds A plus 1, column C holds a request here. Okay. Now when I run this, this is just an example how to extract a column. If you put into two quotes, how would be the output? So column C value is request, column D value is A plus 1, column E value is ABC. Okay, this way. So now you know that how to extract a column. Then what you need to do here for sorting, you know that column function, I can expect a column here. Okay, I can extract a column. Now I know how to extract a column using call function. Now I know that here column equal to column into bracket request. If I use only this much, okay, it holds value, it assigns a value request here in the column variable. Okay, now if you want to just see here, okay, now I'm assigning a value requests to a variable name called column. To a variable name called what? Column. At this moment, I don't have any request column here because it is nothing to do with any data frame. I'm not using any data frame in this cell. So I'm passing value DSC to a request column which do not have any value. Obviously, it throws an error. Rather means null values. Okay. So now, if I use a data frame here, then it is applicable. Now what I do here, I use a data frame. Here I did not use a data frame. Now I use a data frame. Page counts en or df dot order by. Order by is used for sorting a data. Then within that, call COL into bracket request. Okay, here it returns, this function returns what? Requests. This function returns what? Request. For that, you can assign you can pass a DSC. You can pass a DSC. When you use this DSC, it will sort the data. First, you pick up the column, then you assign DSC to that. So since it's a descending order based on request, so you can see this. As per this request column, this much is the data, like 865,692, then it is reduced, like that is the high to low. Highest value, then its lowest value, its lowest value, its lowest value, like that's in descending order, you can see. Now, overall, what I'm trying to say is that if you want to sort a data, first you pick up a column using call function, and for call function, you attach to the data frame, and then you pass a DSC, dot DSC. Data frame into bracket, order by into bracket, column request. It means that you are requesting, you are selecting only column from this data frame, and for that you are assigning a DSC function. Then it's applicable to entire data frame here. That's what you are using a DSC. Otherwise, sort by or order by, you can, one of them we can use it. Okay, that's what here you can use. So if you want to perform any other operations, here few examples are there, like where column value is required. Where column value is required, you require a column value whenever you are checking is null, is not null, is NaN, not null. Okay, so in these functions you need a column value, or as, alias, name, between. Okay, cast operator, you are going to convert from one data type to other data type, cache operator. ASC, ascending order, DSC, descending order. Okay, start with, end with. Okay, I think yesterday I used the one word start with, right? It starts with I. Okay, so here also it is for that also it required one value. Okay, these are all few examples of functions which are related to column, So using these functions, yes, we can perform a kind of a order by. In the same way, filter and where clause. Okay, when you use a filter, you can use a filter with column name. You are going to use column name for filtering the data. Even same thing where also you can use where column. You can see here the syntax is already given. Order by filter. If you are in filter, parameter is column. Filter, your parameter can be a string. Same thing where column, where string. This is what a parameter we can pass to this one. Now how to pass here? Now I want to filter a data where project equal to only en. How did you do it? Here, new data frame, okay, equal to sorted DSCDF. Okay, sorted DSCDF means this is I'm referring this previous data frame in descending order. Here we have made descending order, right? Here. So I'm referring this data frame. So this data frame, from this data frame, I want to select only where there are so many types of projects are here. en.m, en.j, so many projects are there, but I want only those projects which where project equal to only en. So in that case, how do you filter it? So we use a filter, okay, like this. Sorted DSCDF dot where into bracket project equal to en. So it means that I can select only those projects whose project column has a value en. Okay, this is how you are filtering the data. Same thing with the either you can use a filter, either you can use a whereby also same thing. You can use a filter also, you can use a whereby, where also. Sorted DSCDF dot filter. Okay, dot filter. Filter requires a column here. So you can use a column that filter into bracket call project equal to en. So this or this one of them you can use either this. Okay, this would be very easy compared to filter. Because in filter again you are calling a call function, right? So where clause you can use to filter the data. So but both are what same, objective is same. Both filters are data. Okay, both filters are data. One of them you can use. Depends on your understanding. You can use one of them. Right. So this is how you are going to use filter data. In the same way, we have the first and head. Okay. First means it picks up first records. Whatever number you define. Okay. If you don't define, it picks up only first row. Now, suppose if I use first 10 records. First 10 records, if I use means it takes first 10 records it will take. Now, if you want to know what is this, first or head, both are same command. Okay, from the top of the file, it picks up number of records. Head 5 means from top of the file, it picks up 5 records. First 5 means it picks up first 5 records from the top of the file. Okay, you can use one of them. So you can see what is the meaning of these two. If you look at API document, means for everything in Spark, documentation is there. Document is there. Okay, if you use an API document, both first and head, the description, okay, overall the notes is given like this. It returns the first row. Okay, it returns the first row. First parameter is n. N means number of records. Okay, take this example. Now, if I use that, I have articles df. Okay, dot first. it means it selects only whatever first record in that data frame it will pick up. It may be a column name, it may be a water data also. So it picks up here. Okay, so articles df somewhere else I have defined in the top. Okay, here articles df, you can see head 10. Okay, head 10. So here we have filtered the data. Okay, filtered data. So what we have filtered? Filtered data, when you, I can come back here. Somewhere else filtered is there. Where we have filtered the data previously, right? Here. Here, filtered data. We have filtered only those project equal to EN. I am referring this data frame. I am referring this data frame over here, which may be having a number of records. Now, when I want to apply a filter, you can also use this way. Okay, filtered df dot. What it does? Drop byte served means I am dropping byte served column. Right. Then I am going to filter. I want to apply a filter operations after dropping byte served. Filter column article not equal to main page. Filter column article not equal to hyphen. Filter column article not starts with the word special colon. Okay. So wherever these conditions are true, only those records will be taken out. First of all, I'm dropping first column, one column, that's a byte served. So automatically it selects only 3 columns. Next what happened that I'm filtering the data with this condition. What is that condition? In this particular article column, it should not have anywhere word main page. In this second column, it should not have any word with the hyphen. With the hyphen, if it finds hyphen, it drops. And wherever this column start with the special, if any word starts with special, I don't want to take that record. Okay, just I am sorting those records from the entire data set. Okay, after filtering, where I am storing articles df after filter data. Next, what? First 10 records if I want to take. First 10 records. There are so many records, but I want to take only first 10 records. So I can use either take or head. Either take or head. So here if I take a head here, so it automatically from this articles df, first 10 records are being picked up. And head take, these all are not a data frame operation, these are all RDD operations. Okay, that's why the output you can see like a row objects, bottom layer data it will fetching, not like a structured data. Does it like a structured data like how you have seen in the top, like column table type? You are not seeing like a table type. This is the row objects at bottom layer in the RDD. Because of this, that whatever that head or collect or take, these are all RDD operations. So it will fetch directly from the, not through the data frame, directly from the RDD it will fetch. So from the RDD when it fetches, so obviously we know that they are all row objects. They are all row objects. The same this row object we are viewing in the form of table. We are fetching in the form of table using the Spark SQL. So now head means only first 10 records I can take it. Or I can use the first also. I can use the first, how many records you want to extract. I can use, if I don't use any parameter here, first row will be selected. First row can be a column name also. First row can be a column name. So if I want to print here, so it can be what a column name. That would be the first line. That's a project equal to EN, article equal to Midas, request equal to 55210. I think you can see from this data set. From this data set, this is my data set. First 10 records. Out of first 10 records, so you can see that the first row is project equal to en, article equal to midas, request equal to 55210. So here if I use a first, okay, when I use the first operation or first functions, so automatically you can see the first record, en midas requests. Okay, so you can use that first record only you can take, or head you can use in all those things. Collect is also, you know that collect is a RDD operation. See, collect, take, head, these are all RDD operations. You see output in the form of row objects, because at bottom layer elements are stored in the row objects only. Okay, but through data frame, that data we are seeing like a table, like what a table, which we are seeing the data. But that's what we are using a collect, take, head. So data will be seen in the form of a row objects. In the form of what? A row object. You can use also, if you look at API document, collect function is described like this: returns an array that contains all the rows in the data set. Means collect means selects all data. Okay. Collect selects all data, head it selects only required number of data. Collect do not have any parameter that collect only 5 records, collect only 10 records. No, it collects all data. That's what collect is. Collect compared to head, collect and take, collect consumes a lot of resources. Because there is no logic here. You are selecting whatever data is, it just collects. Gather all data. Okay, whereas whereas head and take command selects only selected records. Top 5 records, top 10 records, even top 1 record it goes. So collect is somewhat costly. Okay, so this is few example they have given, like a limit articles df dot limit 10 and collect means you are whatever 10 records you are collecting. Okay, array of object you are collecting in this way. Okay, so now at this moment, so you don't execute this. Okay, so just otherwise if you execute this now, next just try to understand till here. Otherwise it will, when you go down now, you may, it should not get confused for you. Just try to use a limit statement, try to use a take statement, try to use a head statement, which are part of RDD operations. So whenever you use a collect, take and head, always it returns data in the form of row objects. Okay, when you use a show or display, it displays data through the data frame. Otherwise, is collect head and row, collect head and take, it returns data from the RDD. Okay, so this is about what to data version, second one. Okay, can you try something on this? Try it, just take some time and try it, how it works. Data set, data mount is there, na? data mount. Include, go to include, then data set and mount. But only one time you execute. Now, once you execute, tomorrow you need not execute. Because that is already created in your this one. Yeah. Done? Yeah. Last I will tell you. So these three are very important for machine learning. One is filtering, limit, okay, drop, okay, plus you can, if required, you can sort the data and all. Then sometimes you need to convert also some data types. You may create new column also. So for that, so these are also important, some commands. Okay, here in this particular place, in this particular, notebook, what we discuss is like how to perform date related functions. Okay, you know, in SQL and all, you have date functions. Okay, date functions are there. We have some kind of this one aggregate functions are there. Okay, so how to perform them using Spark. So now if you go through this data set, okay, if you run this, okay, here simply what we do that whenever you run a command, If you go back to this diagram here, okay, take any diagram. Your data is here, correct? When you read a data, it will get distributed. Okay, it will get distributed across all nodes. Now, when it distributes data, the data is being stored at bottom layer in the form of partitions. Now, whatever program you submit, so that program will replicate across all partitions. Okay, for example, we have a data. Let us take, we have 3 nodes. Okay, you have 3 nodes. Your data get distributes on all 3 nodes in the form of partitions. Now you submit your job. Okay, you submit a job to a Spark Master. When you submit job to a Spark Master, the Spark Master, their job get distributes on all nodes. Okay, they distributes across all nodes here. Okay, like I said, like a jar file which is get distributed across all nodes in Hadoop. Here also it get distributes across all nodes. So now this job, each job, okay, the job is same, which is replicated everywhere. But this job is performing on this part of the data only at a time. At a time, it performs only on that partition of the data. Right. Now, here, there is one important aspect we should remember, that in a given time, the job will perform exactly on one partition only. Okay. Now, give me here, suppose I have a data in 3 partitions. Okay. 3 nodes are there, 3 partitions are there. Suppose if your job takes 1 minute to complete on one partition. Okay, how much time it takes on 3 nodes? Huh?
So 1 minute, 1 node.
But it's performing parallelly. How much time it takes? 1 minute. Correct. 1 minute. At a time, if your job takes 1 minute, on that partition, it takes 1 minute to complete it. Okay. So it means that if you have 3 partitions and 3 nodes, you need only 1 minute. Okay. Suppose if you define 4 partitions, now not 3 partitions, but 4 partitions. When you 4 partitions here, what data? The first partition will go here, second partition will go here, third partition will go here. What about 4th partition? It will be go on one of them. Here it goes. Okay. So now on node 2, you have 2 partitions. On node 1 and 3, you have unknown partitions. Okay. Are you agree? Yes. Now let us take same example. If your job takes 1 minute to complete on one partition. Okay, but the job is one. I cannot, if I complete the job, I'll not declare my job is done. No. If I want to give it to end result, it ensure that it should complete everything. Then only it is a end result. Okay, now we know that that job is taking 1 minute. So here on partition 1, 1 minute will be taking. On partition 2, 1 minute is taking. On partition 3, 1 minute is taking. 1 minute is over. Now, what about the remaining another? Because 2 partitions are here. When the 2 partitions, again it takes 1 minute here. Right? Just by total, how much time it required here? 2 minutes. Just by adding one extra partition consumes double time. Okay. You have 3 nodes. You have 3 partitions. Yes, it is performing 1 minute. Suppose if you have 4 partitions, okay, until this partition is also over, the job will not be finalized. So then these other nodes should wait until it completes on that partition, second partition, other partition also. So it takes almost double time. It takes almost a double time. So second, suppose we have 3 nodes, but you have only 2 partitions. You have only 2 partitions, are only 2, but you have 3 partitions here. So one partition perform a task here. Here also it perform one task. It completes in 1 minute only. On the other hand, this partition is this node is unutilized. Okay, it means that you are underutilizing your cluster. You are underutilizing what your cluster. Okay, so that should be very properly that one thing is that number of nodes. Okay, number of here number of nodes should equal to number of partitions. It's the ideal best practice. Okay, now if number of nodes are more than number of partitions, what happens? If number of nodes are more than number of partitions, what happens here? Cluster is some nodes are not utilized. Some nodes are not utilized. Okay. Suppose if number of nodes are okay less than number of partitions, what happens here? It requires double time. Okay, so the ideally we should have, okay, ideally we should have number of nodes equal to number of partitions, so that if you want to utilize your cluster optimally, okay, if you want to utilize your cluster optimally, your number of nodes should equal to number of partitions. Okay, this is also one of the performance point. Now, how do you do a partition? Okay, here there are 2 functions. If at all you want to do a partition, there are 2 partitions. One is a partition is a function operation, and coalesce is also one operation. Coalesce and partition. Partition or repartition. Partition or repartition. Okay, partition or repartition. So is a one function, and coalesce is another function which you can use here. So repartition, using repartition, you can increase or you can decrease number of partitions. Suppose today I am making 5 partitions. I have 5 partitions. I can increase to 10, I can decrease to 3 also. Both say I can do it. But in coalesce, okay, you can decrease or keep as it is. You can either you can decrease number of partitions or you can keep as it is partitions. You cannot increase number of partitions using coalesce. Usually there is an interview questions. What is the difference between coalesce and partitions? Should tell that in case of partitions, you can increase or decrease number of partitions, whereas For less sec, you can keep as many partitions you define, or you can decrease number of partitions, not more than that. Okay, so now here when you come back to this, you can just see here. You can set default partitions. Okay, you can set a default partition. अगर आपको कितना चाहिए, I know that this is my cluster. Okay, कितना भी होने दो default this when I move data, the data should get distributed into these partitions. Default is in Spark 2.0 and above. Default partitions are 200. Partitions, logical partitions, 200. Depends. It may be a small, it may be a big. You can also set the size of the partition also. The parameters are there, you can set it. Now, suppose if you want to set up partitions, so you can use this function. That's a environmental variable you can set here, like spark.config.set. Spark.config.set. You can use spark.sql.sepal.partitions and comma number of partitions. Okay. Number of partitions are, how many I am setting here? I am setting 8. So here my default partitions are 8. Okay, means you can, default is 200, but now you don't want 200, so you can set it as a 8 partitions. Okay, so whatever data is here, okay, this data will be, okay, you can repartitions also. Okay, repartition, I said you can increase partitions or you can also decrease partitions. Now default is 8, and if I have a 7, from 7 to 8 I can increase because partitions value is 8 here. Okay, I am reading data from Perquit file, including inferring the schema and caching the data and partitioning the data into 8 partitions. Okay, then I can count the data here. Okay, the count is 720,000 records are there. 720,000 records are there, and these 720,000 records are being distributed in 8 partitions. Okay, into what? 8 partitions. So this is your data actually, whatever that we have seen, the timestamp, site and all. So you can run it. So here you have a 720,000 records. Then you have you are just showing number of records here. Okay. Now, this is what you can use partition part. Second is, means you can decide how many partitions you want. Already, whenever you want to write any program in Java, so these steps you have to follow. One step is you have to read first data. Second, after reading data, you have to balance based on your number of cores or slots. So you can decide number of partitions. That's what balance the number of partitions to the number of slots. Slot means CPUs. How many CPUs are there? That many partitions you can decide. Then cache the data. Okay, cache data is also used for a performance purpose. You can cache the data if you are using that data frequently. Okay, after that, if you want to adjust any partitions, you can adjust the partitions. Okay, you can adjust the partition, then you can perform some ETL operations. Like when an ETL operation means a data processing operations. Like for example, if you want to introduce new column, if you want to change column type, or if you want to, suppose if there is a date column is there, from the date column I want to extract only year, after that, or if I want to extract only month from the entire date, or if I want to extract day of the week, which day of the week, for example, today is the 18th 12, so which day of the week today? So it is what maybe a 7th day of the week. Okay, which day of the quarter? Okay, this is in a 4th quarter, and in 4th quarter already 2 quarters are 60 days, 60 plus 18, it's the 78th day of the quarter. Which day of the year? Okay, you can all find out based on functions. Year function which extract only year, month function which extract month only, date of the week means it extract day of the week, day name of the week, day number of the week, okay, day number of the month, day number of the year, quarter, all you can extract because there are some functions available. Okay, so now just for example, if you see a data here, some initial data, let us see. Initial data is this, whatever we have read the data na, timestamp, site and request. So the timestamp is what this way, 2015-03-27. So 27 might be a date. Okay, it is in the form of a year, month and date. Some time also is there. Site, okay, from which site you are requesting for an article, whether you are requesting through mobile or desktop, and how many requests are there. Okay, this is a sample date. And since it is a text file, okay, obviously this column is a string data type. If this column is always, because you are reading from the text file. Okay, because if you are reading from the database, date column is there in the date column, data type. But if you are reading data from the text file, is always in the form of string. The type is always string. When you have a string data type, okay, you cannot perform date functions on that. Because when you want to perform any date operations, you should have a date type column. You should have a date type column. Right. Now, what happened that if you want to see what type of data it is, okay, you can just see here. Okay, if I want to just instead of print date, instead of print here, I can also print schema. I can use it. Print schema. When I use a print schema, so you can see that timestamp is the name of the column. Its type is a string because it is in the text file. Second column is a site. Anyway, it is a mobile or a desktop. It's coming. It's a string. Request is a column which is having an integer. Okay, now on timestamp, you cannot perform any. Timestamp is a column name, not a data type. Data type is a string, right? So now you cannot perform any date operations on the timestamp column unless and until you convert that string into timestamp. Okay, string into a timestamp. When you want to convert into a string into timestamp, if I convert the timestamp into timestamp, it will get confused, right? Timestamp is also column name and type is also timestamp. So what I can do, I can temporarily, okay, rename this timestamp as a different column. Okay, in order to rename a column, there is a function called with column rename. With column renamed is a function which you can use to renaming a column. Okay, with column is also one more function which you can use to derive new column. Agar based on 1, 2, 3 column, I want to derive 4th column. Okay, like for example, I have an item, I have a quantity, I want to derive a total column. Total equal to item into quantity. So to derive a new column, we use a with column. Select is also used to selecting a column. Now let us see how to use them. Okay. So first, how to use initial df we have a here. All column names here. These are the timestamp, site and request. So I refer that initial df dot select. Select is used for what purpose? Selecting a column. So what are the columns you have selected here? I want to select 3 columns. So one is a timestamp column, and this timestamp column I can rename as a captured at. Okay, I want to rename as a captured at. Now there is no more timestamp name of the column. It is called now you are renaming a column as a captured at. Site as it is column name, request also as it is column name. If I want to print the schema here, so what happens here? It see the outdate. The first column name is a captured at. Second column is a anyway site it is, request it is. But still I am not yet converting column name, column type. Only I am just making a column name. This is one option. Select is also one option to renaming a column using alias. I think you SQL में भी alias use करता है ना, changing the column name. So this is also same. Alias can be used for renaming a column. Second, this is one way. Now this is second way I can use. One using a select, you can rename a column, or using with column rename. Whatever column is there, I want to rename into a new column. So here initial df has what? A timestamp, site and request. Okay, now I will refer timestamp column, I will rename it as a captured at. Okay, you can rename any column. You can rename any column. So now I know that timestamp was my original column. I want to rename as a captured at that I want to save into a my df1. I can do that. So print schema anyhow you are using, so it prints. Now you can see this is a captured at. You can give anything. Here suppose if I give a captured at 1, 2, 3. Okay, it rename as a captured at 1, 2, 3. You are renaming the column. That is also, this is a with column renamed is also one option which you can use for renaming a column. Now this is the second option you have. Third option, you can also use 2df. 2df is also one function. You are referring one data frame. Based on that data frame, you are creating a new data frame with new names. Okay, 2df is also one option. Okay, now initial def is my old data frame. I am using this initial def and I am converting into a new data frame using a function called a 2df. Initial data frame dot 2df. I am creating a new data frame with a new name. Totally all columns I can rename, or only required column I can rename. Now, which is easy for you? These are the 3 alternatives. These are the 3 alternatives. So whichever you want, you can use it to renaming a column or selecting the column. Now, if you want to rename this, so now you can see here captured at, site and request. Okay. Now you know there are 3 options where you can rename a column. One is using select. Second one is with column rename. Third is what? 2df. Using 2df also you can rename a column. Now you are only renaming a column. You are not converting type. Type is as it is string only. Okay, when it is as long as you have a string, you can perform string operations, but not a date operations. Now, if I want to perform a date operations, you have to convert. You have to convert that string data type into timestamp data type. You have to convert. So to convert from a string into timestamp, the first you have to convert into a Unix timestamp. Okay, in certain format you convert. Okay, there is a function called a Unix underscore timestamp function through which you can convert your string data type into a Unix timestamp in certain format. Okay, that you can define. And cast operator you can use. I think cast operator also in Python you might have seen. Cast operator converts from one data type to another data type. CAST cast operator, you can use it. Now, let us see how to use here. You can see here. If you want to know more about Unix timestamp, so the first function is a Unix timestamp. If you look at the documentation, what they have given, it converts a time string. In the sense, it converts the string in time, time in string format with given pattern. Which pattern you give? Okay, whether MMDDYY you give or month DD you can give it, whichever pattern you give, it converts into that pattern. Right. So now let us convert into this pattern YY because the date is also having this same format. Na? Here YY 2015 03, I think 16 22 something, YY and DD format. So now I can convert that same thing YY DD. So how do you do it? Initial DF, the first, which is having 3 columns, that is timestamp, site and request. And now what I'm doing in the first part, I'm renaming timestamp as a capture date. I'm reading one data frame, only renaming only one column, that's a timestamp, into a capture date. Okay, then what I'm doing, so the output of this generates only one column because you are selecting only one column. Now that column I am converting into Unix timestamp. I'm selecting only that column here, and that column I am converting that captured at into this format. That's what a Unix timestamp. I'm converting string into first a Unix timestamp. It means that you have a text and bottom level is what you are storing. So this data you have to convert into a object readable. That's what a Unix timestamp. Okay, now when I use this here, okay, your first column is there as it is captured at, second column is site, third column is a request. Now this column you are printing as it is Unix timestamp. Okay, its type, when you are converting into Unix timestamp column, it converts into a long format. It converts into a long format. So long format means it is in a Java object. When it is a Java object, you cannot see the data. You have to do some iteration on that. So unless and until you convert the long data type into a timestamp, you cannot see the data. Okay, so now you have converted here. Now if you convert this, so you are converting into this format YYMMDD So now this timestamp you can convert. Suppose if I want to see this data, you will not see the data here. Okay, you will not see the data here. You will see data. Yeah, Unix timestamp. So you can see the data here, null, because it's in a Java objects, converting into lower level. So now this Unix timestamp we can convert into a timestamp using a cast operator. So when you use the same output, you can pass it to a cast operator here. Okay, select column star Unix timestamp, this output. You convert dot cast. Okay, and which format you want to, which data type you want to convert? You want to timestamp. So when I run this, so obviously you can see the last column is this. Okay, but you are not, I can use as an alias as a some column name. Because I can use the alias as a column, because this entire expression is considered as a column name. Now if I want to rename this column, I can use an alias. Okay, I can use an alias here, or I can use that same column also. Now anyway, I have converted into a timestamp, and if I see this data, so that you can see the data also. Now this is our actual original data, which is in text format or a string format. After converting, so this is actually a timestamp format. 2015, 03, 27, okay, whatever timestamp. So now, once I convert into a timestamp on this, I can perform all date operations. Okay, date operation means, suppose if I want to pick up only year, if I want to pick up only month, or if I want to pick up only date, day of the year, day of the month, day of the quarter, all operations I can perform on this particular column. not on this column. Not on this column because it is a string data type. Okay, you have to convert and perform the task here. So now, see here, there are so many options are there. Okay, now you can rename that column. Okay, now I don't want to take as it is a big column name expression. I can rename with the alias. Okay, now when I print this, so here you can see that your column name is entire expression is there. Okay, so I can rename this as a just I can attach here alias column name. Alias what? Column name if I use here, the same command. So I'm renaming here as a capture data, and you can see the time data type is what? Timestamp. The first one is capture data as a string data type. Now capture data I'm converted into a timestamp here. Once I have a timestamp, then I can perform different operations. Okay, this is one option. You can use other options also. With column also you can use. Okay, so this is very simplest to understand. So there are options. You can use any options to convert into a data frame. There are so many options are there. So now let us stick to only one options. Then after converting that, you can use these functions. Year function, which returns year. Month function, it returns month number. Day of the year. Okay, it returns a day of the year. Whatever day number of the year, it will return here. Okay, so now if I use a display, how we are using, so select year, that column name. Select year, that column name if I use, it selects only the first year. So why it is giving here? The problem is I'm not running in between commands. So I will take which I executed lastly. Temp B I will take it. Because temp B has this all data. Even not this temp B, alias I can use it. Here. Yeah, option A I can use it. This. Temp C I will take. I will take a temp C. I can go down. Because it is all here. Otherwise, I have to execute all option 1, option 2, option 3. So no, not this. Go back to here. Month here. I'll use this instead of temp C. I will use temp C dot select because capture that column is there, and I can just simply run it. It's required to execute. 1 minute. Here, right? Alias. If I use here, when I use this much, so now I have to execute this command actually. The remaining part I have to execute, one of this execute. So here, okay, you can use like a year, how I am using the select year function. Simply pass that parameter. It returns what a year of so many years are there here. 2015, only year part will be extracted. If I take a day of the year, month number, it takes only 3, whatever months are there, it will pick up only month. Okay. And third function is a day of the year. It will pick up the day of the year. Based on your date, it will pick up day of the year like this. So month returns what? 2015 3, 2015 4. When I pick up a month, okay, month number will be picked up, day of the year will be picked up. Okay. Then after that, if you want to perform a group by clause on that, okay, you can perform a group by operations also. Okay, so group by already you know that it's a wide operations because data gets shuffled between multiple slots, multiple partitions. The data gets shuffled, so we use a group by clause. And when you use a group by clause, so we have so many functions like group by with the average, count, sum, mini, max, all aggregate functions you can use over here. Okay, so these whatever we have seen right from reading data into any format, then transforming the data using transformation operations, viewing the data, okay, using action operations. Okay, so what are the operations we have seen since afternoon? First morning, anyway, we have read the data. We brought the data which may be a TSV, CSV, per quit and all. Now after bringing data, what are the transformation operations we have seen? Limit, drop, select, distinct, drop duplicates, order by, sort, filter, what is that? Where clause. Okay, then we are using some functions here. Okay, converting from, you are renaming a column with an alias. You can rename a column with a select statement. You can rename a column with a do to df. Okay, then you can convert column from string into Unix data type, and from Unix data type into you can convert into a timestamp using cast operator. Okay, so like this, so you can do as part of our data frame operations here. So after that, this all it is used as part of your pre-processing. If you want to pre-process your data in say Spark, okay, so you can use these all functions. Then there are few libraries which you have to import. I think you people might be much expert than me in case of machine learning. So which I may not go through all, but I can just explain you in terms of machine learning. Okay, very few. We'll talk about introduction to machine learning. Maximum I may go only with a linear regression. बाकी आप लोग logistic regression, neural networks अगर चाहिए तो आप देख सकते हैं. K means algorithm and all. Okay, you people are very much aware. Okay, so how to use machine learning? Okay, using Spark, like you have to create a pipeline, you have to create some estimators and all. So I'll just show that, then you can execute it. Okay, so this I will tell tomorrow. Okay, so tomorrow what time shall we meet and how to meet? इधर ऑफिस चलो है तो देखना पड़ेगा क्योंकि at by any cost में ज्यादा नहीं रहेगा, मे बी मैक्सिमम मेरा 3:25 को ट्रेन है, 3:25 को ट्रेन है तो आई हैव टू लीव एट 2:30 फ्रॉम माय होम. नहीं, 2 o'clock I have to leave. 2 o'clock I have to leave means I should be there by 1 o'clock in my home. Maximum at the very worst case I can go up to maximum only 12 o'clock. ऑनलाइन है तो दे सकता है, मैं एक्सटेंड कर सकता है उधर ऑनलाइन से. ऑनलाइन है तो मुझको प्रॉब्लम नहीं, कभी भी सुबह कितना बजे को बोल सकता है, कितना बजे को भी छोड़ सकता है, क्योंकि मेरा 2 घंटा बच सकता है ना इधर आने का जाने का. साढ़े 8 म्हणजे 8:30 पक्का, म्हणजे ऐसा नहीं वो 8:30, 9:30, 10:30, 11:30. तो इसलिए मैं थोड़ा एक्सटेंड किया आज. No, 12 का अंदर मैं छोड़ने वाला. I'm damn sure because I don't want to get at the end. नहीं 9 मीन्स तुम लोग को टाइम कम मिलेगा, मैं बोल रहा हूँ। सो आपको ऑनलाइन है तो नो प्रॉब्लम, एनी टाइम आप, नो नीड टू सी योर, तुम लोग को भी ट्रैवल बचेगा। ओके, मेरा भी ट्रैवल बचेगा। आई ऑल्सो,
ऑफलाइन में अटेंशन ज्यादा होता है।
वो तो है। टेंशन मुझको प्रॉब्लम नहीं, 8 8:30 8:30 आई विल कम, क्योंकि मेरा कल कुछ भी नहीं, मेरा उठने का, मेरा तो उठने का 5:30 को तो उठता हूँ मैं, क्योंकि मेरा तो ज्यादा से ज्यादा 1 घंटा थोड़ा इधर उधर स्ट्रेचिंग कर कर मैं स्नान कर कर मैं डायरेक्टली आ सकता हूँ।
मंडे है ना, मंडे
क्या, क्योंकि टुमारो वुड बी द लास्ट फॉर यू, आई थिंक। अगर अगर नेक्स्ट वीक चाहे तो नेक्स्ट वीक में मैं मंडे फ्री है, नेक्स्ट वीक मंडे फ्री है मैं, क्योंकि मैं मैक्स 12 डॉट आई हैव टू लीव।
ओके ओके ओके, फ्रॉम 8:30
हाँ, मुझको प्रॉब्लम नहीं, आई कैन कम से 8:30 का उधर बैठने का मैं, क्योंकि सुबह में आधा घंटा में आ सकता हूँ, 12 बजे को पट से आधा घंटे में, आधा घंटा में जा सकता हूँ मैं कल। क्योंकि ये थोड़ा पीपीटी एक्सप्लेन करने का है आपका, इतना 4-5 पीपीटी है। ओके, ठीक है। ओके श्रेयस, who else is it?
Yes, sir. Yes.
Shreyas,
Yes, sir.
okay, I can leave meeting na?
Yes, yes.
Okay.